All right, so next up, we're talking about the cerebellum. So, the cerebellum coordinates voluntary movement and it also makes corrections. The cerebellum compares these two signals: the action signal that's being sent out from the brain for us to execute a motor command, and then the sensory signal about how that motor command is actually being executed. So the cerebellum gets both of those signals and it compares those two. And so if there's any misalignment, it can make online corrections without consulting the cortex to correct that action. So it makes these online corrections without consulting your consciousness, essentially. Um, Alcohol affects the cerebellum because the primary neurotransmitter in the cerebellum is called glutamate, and alcohol inhibits glutamate receptors. So when we're drunk, when people are drunk, it is disproportionately affecting their cerebellum, which is why they get slurred speech. And it's why they can be a little stumbly, because basically what's happening is that the cerebellum is not working effectively. And so either the signal that's being sent about what actions to take is going out too late, or the information that it's collecting from the body about how that's being executed is not happening quickly enough, or the online corrections that it's making to try to fix the misalignment are either too late, too early, overshooting, and so you end up being a little bit stumbly. Damage to the cerebellum actually can look a lot like people who are intoxicated. So it could be intoxication. It could just actually be damage to the cerebellum. Interestingly, the cerebellum plays a role in verbal learning. And that's learning to make a verbal response when a specific stimulus is presented. And that's because one of the most complex fine motor movements that we do on a regular basis is speak. Do you know how much fine motor movement is happening here? Are you impressed with how good I'm talking? Probably not. So, uh, when we are trying to remember verbal information, we actually engage in subvocal articulation, and we use the same parts of the brain that are involved in speaking for subvocal articulation. So it makes a lot of sense that the cerebellum will play a role in verbal learning, because in order to actually remember verbal information, you tend to execute verbal information, even if it's not out loud. All right, so next up, we're going to move on to the limbic system. So the limbic literally translates from Latin into the rim, and so it's the rim, and it's this rim of structures. When you pull apart the two hemispheres, it's the rim of structures that sits right around the cortical structures, essentially, and so. That rim is sort of all connected, a series of structures that are all connected. And the limbic system has been implicated in processing olfaction, so sense of smell, emotion, and encoding and retrieval of certain forms of memory. So if you look at this figure right here, you're going to see that little purple antenna that's kind of sticking out from the front of the brain. And that purple antenna that's directly connected to the limbic system is actually your olfactory bulb. That is where your sense of smell is being processed. So you can see why it would skip the thalamus here, because, I mean, it's literally closer to the limbic system. But what's interesting is that because olfaction is connected to the limbic system, smell is also the sense that is most strongly associated with both emotion and memory. And so you might walk out on an early day in fall, and you go outside and it's like that crisp, fresh air, and you take a big, deep breath, and you can smell like the leaves, and like the leaves changing, and it smells different, right? And that just big that big inhalation might actually trigger an emotional memory for you about, your first day of school in grade 1, for example. And that's because the olfactory bulb, it's right there connected to the amygdala, which is highly involved in processing emotion, which is itself connected to the hippocampus, involved in processing memory. There we go, man. All together. Damage to Damage to the limbic system can result in difficulty with the organization and recall of long-term memories, but it also can result in behavioral problems. So this was discovered by a pair of researchers, Kluver and Busey, who were interested in trying to figure out what the amygdala does. So they were specifically interested in the amygdala. And the amygdala was implicated in the processing of emotion after Kluver and Busey removed the amygdala in primates in order to see what happened. And what happened essentially is that the monkeys that they were working with exhibited unusual tameness, and they were very aggressive. Monkeys actually are very aggressive animals, and following removal of the amygdala, they became really tame. They also reacted to fear-relevant stimuli inappropriately. Monkeys have a reflexive fear of snakes. Even if they've never seen a snake, they will show like profound fear to it. You can see this monkey here, one of the Kluver-Busey monkeys, with his amygdala removed, is just clearly, without fear or hesitation, reaching out and interacting with it. It's a toy snake, but generally monkeys would not be willing to interact with even a toy snake. So that's very, very, very atypical. And the idea is that Kluver and Busey came up with for this syndrome that they identified is that first of all, it implicated the amygdala in the processing of emotion. But in particular, what Kluver and Busey proposed was that the amygdala was involved in the connections between sensory properties and their affective properties. So this is sort of an interesting and unusual way to think about emotion and affect. But we actually have emotion about things that we like to eat, literally. Like, that something is edible because you like to eat it. So there is like an affective component to that. And how we interact with objects is often based on how we feel about the objects. So the idea here is that with the amygdala helps us to connect that sensory information with how we feel about that object. And with that connection broken in Kluver-Busey syndrome, what you see is animals that will behave inappropriately towards stimuli and based on its affective properties. So monkeys with Kluver-Busey syndrome will often try to eat inedible things like chairs or the walls. They will often try to copulate or have sex with inanimate objects or other animals that are not monkeys. And so they exhibit all sorts of behavioral problems that all really seem to come down between a break between sensory information and the affective properties of that object. Humans also experience Kluver-Busey syndrome, but the presentation of Kluver-Busey syndrome in humans can actually look a little bit different. We're a little bit more complex, and patients with Kluver-Busey syndrome can show unusual tameness. But they actually also might show unusual levels of aggression. And damage to the amygdala can also result in aggressive behavior because the amygdala is involved in processing of fear and emotion in particular. So Charles Whitman was an American engineering student at the University of Texas. He was a former U.S. Marine and a mass murderer who killed 16 people starting with his mother and his wife. And then following that, he went to school and climbed the clock tower at the University of Texas and started shooting people. That mass shooting went on for 90 minutes before Charles Whitman was killed by police officers. During his post-mortem, the pathologist found that Charles Whitman had a tumor that was pressing up against his amygdala, and Whitman's medical condition was likely in some ways responsible for the attack. But it's sort of interesting because when I hear conversations about Charles Whitman, it's about his experience as a U.S. Marine, or the relationship that he had with his mother or his parents, and this gets left out. This idea that like there's an amygdala or a tumor pressing up against his amygdala. Maybe that was the reason. Charles Whitman did also, because he was a vet, he did go to the VA hospital and talk to his doctors about feeling intense rage. He felt like there was something wrong with him, and he tried several times to reach out for mental health assistance, and he just was not taken seriously enough. He wrote a letter after murdering his mother and wife, and prior to going to the University of Texas, he basically wrote a letter that said, "I just killed my mother and my wife, who I both love dearly. I don't know what's wrong with me. I don't know why I'm doing this, but I'm compelled to engage in these acts of violence." I think that's interesting, and I think it's worth thinking about. All right, so below the thalamus is a structure called the hypothalamus, which is convenient because hypo means below and thalamus means thalamus. So that's convenient. And the thalamus is actually a structure that controls endocrine function and is involved with basic homeostasis. Homeostasis is that maintenance of the normal state of the body. So different nuclei receive different information about when the body is out of equilibrium. And then the hypothalamus will relay that information to the cortex so that appropriate behavior can be taken to initiate, to counteract the imbalance. So the hypothalamus is monitoring food intake, water intake, temperature of the skin, and blood pressure. And what it's doing is monitoring those levels and then triggering either hunger or thirst or some sort of motivation for us to do something to address the imbalance of the homeostatic imbalance that we're experiencing. The hypothalamus is also involved in the fight or flight response. So it helps to trigger that fight or flight by releasing hormones and neurotransmitters in the brain in order for us to act. And then what I want you to take note of here is that there is this structure called the optic chiasm that sits right below the hypothalamic nuclei. That is the part of the brain where the signals from the eyes actually cross over for that contralateral organization. And so it's this structure that actually processes light-dark cycles, and as a result, the hypothalamus is getting that information. So it's helping to regulate when it is that we go to sleep, when we start to feel tired, and when we should feel a little bit more awake. It's also considered a pleasure center. So it's one of the parts of the brain that is activated when we're feeling pleasure. And then finally, this blue structure that sort of wraps all the way around, but you can see it gets a little bit fatter right at the end near the amygdala. That's the hippocampus. And the hippocampus is, I already said the thalamus is my favorite subcortical structure. Okay, so that means that the hippocampus is my second favorite? No, they're both my favorite. I love them equally. The hippocampus processes conscious memories. It does so much more than that, but it's kind of its main role. And conscious memories are memories that we can actually talk about. and like, what you ate for breakfast or how many siblings you have. Any information that you can access consciously is going to be relayed through the hippocampus. Without it, we cannot form new memories or recall old memories effectively or appropriately. Now, I'm just going to leave it there because we will be talking more about the hippocampus when we get to memory. So let's come back to you, hippocampus.